Use cases. In this section, we will explore 4 use cases for Docker. First, we'll learn how to use Docker to test backups and changes with MySQL. Second, we'll deploy WordPress in MySQL. Third, we'll learn how to use Docker to manage applications with a lot of dependencies. Fourth, we'll learn how to deploy Jenkins. Rapidly test backups and database changes with MySQL. In this video, we'll learn how to use Docker to help verify MySQL backups and aid in testing changes. We'll start by learning how Docker can help with these tasks. Next, we'll learn how to start MySQL and import data. We'll then learn how to back up and restore data from a MySQL container. Finally, we'll discuss the testing cycle with Docker. Docker is a powerful tool for running applications, but it can also be a powerful tool for testing and debugging. One of the things I like to be able to do with Docker is use it to test my MySQL backups. The other thing I like to do with Docker is test database changes that may be required by application updates. The examples in this section use the MariaDB fork of MySQL. MariaDB was created by the original MySQL developers after Oracle purchased Sun Microsystems to ensure that a version of MySQL remained open source. MariaDB is completely compatible with MySQL and can be used as a drop-in replacement for it. In fact, the commands and configurations still use MySQL. Some Linux distributions, including Red Hat Enterprise Linux 7 and Debian, install MariaDB instead of MySQL. MariaDB includes the Galera clustering engine, which provides active-active clustering. This makes it easier to scale horizontally to meet the needs of your application. This is especially nice when used with a Docker orchestration tool such as Kubernetes or Docker Swarm to scale the service as needed. Before we can create our MySQL container, we need to create an environment file that contains the root and database user passwords, default database, and database user. The first time the container is run, if /var/lib/mysql is empty, the MySQL root password is set to the value of mysql_root_password. If you have set mysql_database, an empty database with that name is created. The user specified in mysql_user is granted full access to that database using the password set in mysql_password. In this example, we'll create a database and a user named test. We'll also set the password for the test user and the root password to password. You should obviously use something stronger in production. Let's start a MySQL server. We're going to use 2 volumes for the server. MySQL uses /var/lib/mysql to store its data. I'm going to map that in from mysql/data in my home directory. You can use whatever is convenient for you. We're also going to use a volume to store the database backups. You can put them anywhere, but we'll use /var/backups for these examples. I'm using mysql/backups in my home directory. Once again, feel free to use a different location. The environment file we saw earlier is passed to Docker with the --env-file flag. And we can see that our MySQL container is running. Let's load some sample data, which I generated using generatedata.com. This creates a single table named people and populates it with the sample data. We'll use the MySQL client in the running server container to load the data. Because we're using the -i flag to Docker exec, we can redirect the data from our local desktop to standard in for MySQL. Notice that we can use the environment variables in the container to log into the database. This process will also allow you to import data that was exported with the MySQL dump tool. Let's connect to the server and see what's there. We can use Docker exec again to use the MySQL client. Remember to use the -t flag to create a sudo tty. We can now query the database. There were 100 rows in the sample data, and they all seem to have been imported. Let's show the first 3 rows to just get a feel for what this data looks like. We can now begin to do things with the database. The MariaDB container includes the Percona Extra Backup utility for hot backup of MySQL databases. If you want to use the official MySQL database, you need to build your own image that adds extra backup. This is left as an exercise for the viewer. Extra backup could be used to create full and incremental backups of MySQL. For simplicity, we'll create full backups. The basic script to pull the backups looks like this. This script creates a timestamped directory in /var/backups, then runs extra backup --backup to pull the backup and extra backup --prepare to prepare a backup for recovery. Note that the timestamp uses the time zone from the container, which is UTC by default. The prepare step can be run any time prior to recovering the backup. It ensures that the backups are point-in-time consistent. I like to run it immediately after the backup so that I know that my backups are ready to restore. It also means that I can run the restore with a single command, which will be useful later. It is safe to run the prepare step multiple times on the same backup. This script can be added to your own custom extension of the MariaDB image and run with Docker exec. If you don't want to modify the MariaDB image, you can run the command separately with Docker exec. Let's see what that looks like. This script is very similar to the previous one. It takes the name of the container as an argument, but defaults to MySQL. The variable exec is an alias for Docker exec and the container name, while exec_sh is an alias for Docker exec sh-c. Anything run using the latter is passed to sh-c in the container, which helps with variable substitution. The variables backup and prepare contain the backup and prepare commands which will be run in the container. Notice that we have to escape the $sign from mysql_root_password, so that substitution doesn't happen until it is run with Docker exec. These three lines at the end of the script create the backup directory, run extra backup --backup, and extra backup --prepare in the running container. Let's pull a backup. There's a lot of log output here. You want to look for the lines that say completed OK to ensure that your backup succeeded successfully. If we look in the directory that we mounted in the container, we can see the backup. Remember, I mounted it from mysql/backups in my home directory. And there's the backup we just created. Restoring a backup is pretty simple, but there are a couple of things that you need to be aware of first. MySQL must be stopped in order to do a restore. Also, the data directory must be empty. To meet the first requirement, we'll use the -- entry point flag to override the default startup script for the container. In this case, we'll set it to extra backup. For the second requirement, we'll mount a different empty directory to /var/lib/mysql. In this case, I'll mount mysql/restore from my home directory. The -- copy -back flag tells extra backup to copy the backup to /var/lib/mysql. In other words, restore the backup. The -- target -dir flag specifies the location of the backup. The date is the one we picked from mysql/backups. Notice that we don't need the env-file flag because we're not starting the MySQL server. This will run and copy everything back. If it succeeds, you should see completed OK at the end. At this point, the database is ready to be restarted. Now we can start MySQL again. This is basically the same command we used to start MySQL before. The name is different since the original database container is still running. I am also using mysql/restore for /var/lib/mysql. This will load our restored data. Note that we need to change the published port number so that we don't conflict with the original MySQL server container, which is, again, still running. We can now connect to the mysql-restore container and run any tests that are needed to verify that the data was restored properly. The backup and restore process described here can become the basis for testing database changes. With Docker and a copy of the backup, you can make changes to your local copy as often as needed. If the changes cause problems with your tests, simply stop the container, delete the data directory, and rerun the restore. In this video, we learned how to use Docker to help verify MySQL backups and aid in testing changes. We started by learning how Docker can help with these changes. Next, we learned how to start MySQL and import data. We then learned how to back up and restore data from a MySQL container. Finally, we discussed the testing cycle with Docker.